Hi, this is Dr. G. Vikas Paul.
Hi, this is Dr. G. Vikas Paul. In this session, we'll discuss about a problem on angle section. Okay, to find how to find stresses for the section and deflection of beam. A simply supported beam of span 3 meter. There is a simply supported beam of span 3 meters. Carries a load of 500 Newton at its center. So it has a load of 500 Newton at its center. Okay, this is a beam, simply supported beam. The section of the beam is an equal angle. Okay, the section is angle section. This is angle section. Equal angle of size 100 mm by 100 mm. This is 100 mm. This is 100 mm. Okay, this is 100 mm. This is 100 mm. And 12.5 thickness. Thickness is 12.5 mm. 12.5 mm thickness, as shown in the figure. The load line passes through centroid G of the section. Okay, the load line passes through centroid G of the section. It passes through the centroid. Determine first stress at points A, B and C. We need to determine stress at A, stress at B, stress at C of mid section of the beam. That means at mid section of the beam A, B, C. And then deflection of beam at the mid section. At mid section, what is the deflection? And the position of neutral axis, and position of neutral axis also we need to find. Take capital equal to 2 into 10 power 5 Newton per mm square. Okay, so length is given, W is given 500 Newton, size is given 100 by 100 by 12.5 mm. E value is also given. This is the section. Now, first of all, we need to find the location of center of gravity of this given angle. Okay, this is angle. I have divided into two parts. First part, second part. Okay, now we need to find center. The formula is x bar y bar. For x bar, a1 x1 plus a2 x2 by a1 plus a2. To find y bar, the formula is a1 y1 plus a2 y2 by a1 plus a2. Now what is a1 here? Area of this particular rectangular section, first one. So it is 100 into 12.5. x1. So suppose it is the origin, this is x-axis, this is y-axis. x1 means distance of a centroid of the first portion. This centroid is at the center for this portion. So this distance from 0, from origin, is x1. So it is 100 divided by 2. 100 divided by 2. Next, A2. A2 is the area of the second portion. That is 12.5 into this one, this height. This is 100 minus 12.5. That is 87.5. Okay. So A2. This is A2. Next x2. x2 is, what is x2? From here, the central distance of second portion. x2 12.5 divided by 2. Then a1, this is a1, this is a2. y1 is this vertical distance of this centroid. This is y1, 12.5 by 2. Okay, 12.5 by 2. Next y2. a2 is same. y2 is this one. What is from base the centroid of second portion distance, this distance, this is 12.5 plus half of this, 87.5 by 2. Okay, if you simplify it, solve it, we'll get this one, 29.58, 29.5. That means x bar is 29 at a distance of 29.58. Okay, and 29.58. Okay, yeah, x bar is at a distance of 29.58 and 29.58. This is the centroid. Okay, this is the centroid. Now, moment of inertia about x-axis. The formula is ixx equal to ixx1 plus ixx2. ixx1 equal to ig1 plus a1 h1 square, ig2 plus a2 h2 square. Now what is ig1? bd cube by 12, b1 d1 cube by 12. 1 means this is related to first portion, this is related to second portion. bd cube by 12 plus a1 into h1. The formula for h1 is y bar minus y1. y bar minus y1. So y bar we know, y bar minus y. h2 means y bar minus y2. Okay, now everything we know. b1, so for first portion b1 is 100, d1 is 12.5. Okay, next a1 100 into 12.5, Next y bar is, here we have found y bar 29.58 minus y1 already we know 12.5 divided by 2. Okay, here again b2, here b2 is 12.5, d is this one, and a2 this one area, y bar this is 29.52 by 8, y2 is this one. Okay, 12.5 plus 87.5 by 2. Okay, if we solve this, we'll get ixx. Similarly, we can solve iyy. The formula here is iyy1 plus iyy2, ig1 plus a1 k1 square, ig2 plus a2 k2 square, ig is db cube by 12. Okay, so d1 b1 cube by 12. This is d2 b2 cube by 12. a1 k1 square. So what is k1? X bar minus x1. X bar already we have found here 29.5. x1 from this figure we can say x 100 by 2. And here also db cube by 12 for second section. Okay, and a2 x bar minus x2. x2 is this one, x bar is this one. Okay, from this we can get the iyy value. If you see here, we will get ixx equal to iyy because it is an equal section. Whenever there is an equal section, we will get ixx equal to iyy. Now what is product of inertia? Ixy equal to a1 h1 k1 plus a2 h2 k2. Now what is h1 here? a1 a2 we know. h1 is y bar minus y1. So y bar we know, y1 we know. If you substitute, you are getting this one. But we need to take minus 33 mm based on quadrant, because see, this is our new x-axis, y-axis. Okay. Now from here we need to take y bar minus y1. Now this is your y bar. Okay. This is my y1. Y bar minus y1 is nothing but this distance. So it is below x-axis, therefore minus, negative. Okay, so minus 23.33, and h2 equal to y bar minus y2, y bar minus y2, that means y2 minus y bar, this distance, this one, above x-axis. Okay, so even we are getting minus value, we need to take plus. k1 equal to x bar minus x1. Okay, x bar is 29.58 and x1 is 50. So this one to the right side of this y axis. Therefore, even we are getting minus, we should take positive to the right side now. So x bar minus x2 k2. X bar minus x2 is this one. That means left side of y. So even we are getting positive value, we need to take minus value. Okay. Now substitute all the values in this formula. Okay, you will get this one, ixy as this one. Okay, now we need to find the position of principal axis. Formula we know, tan theta equal to 2 ixy by ixx minus I by y. This value just now we have found, this also we have found, this also we have found. See, this is becoming 0. So tan 2 theta equal to infinity, which is equal to tan 90. So tan 90 is infinity, we know this. So from here we can write 2 theta equal to 90 degrees, theta equal to 45 degrees, and theta 1 equal to 45 degrees, theta 2 equal to 90 plus 45, 135. So it is the x-axis, y-axis now from centroid. Now theta 1 is 45 degrees. Okay, so 45 degrees. Okay, 45 degrees. Now, so this is UU, and this is shifted to 45 degrees here, from here. This is VV, or 90 plus 45, 135 we can write from here. Okay, UU and VV. X-axis shifted to UU, YY is shifted to VV. Okay, this is position of principal UU and VV axis. Now, principal moment of inertia. As 2 theta is equal to 90 degrees, the formula to find IUU is this one. This is the formula. In the previous case, as the 2 theta is not equal to 90, we have another formula, that is secant related formula. But here, as 2 theta equal to 90 degrees, the formula will change. IUU equal to IXS plus IY by 2, IXS minus IY by 2. This is YY. Okay, YY, not UU. YY by 2, YY by 2. Into cos 2 theta minus IXY sin 2 theta. This we know, this we know, this we know, this we know, this theta we know. This also we know. Substitute all the values, you will get IUU as 3445567 mm power 4. Now, as we know this relation, we can find IVV. So IVV equal to IXS plus IVV minus IUU. This is IVV. Okay. Now, how to find stresses at the point A, B, and C? At A, B, and C. 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 At A, B So this is the formula, sigma equal to MUU by IUU into V plus MVV by IVV into U. Now what is MVV? MUU, M cos theta. What is M? Bending moment at midspan. So this is a given problem. Simply supported case with point loaded center. For this case, we know that maximum bending moment is WL by 4. Okay. So what is W here? 500 into L is 3 into 10 cube mm divided by 4. So 375,000 Newton per mm. That is your M value. So cos 45 degrees. MU equal to this value. Okay. MVV is M sin theta. So 375,000 sin 45 is this one. So MU is over, MVV is over. Now how to find V and U? That is a formula. U equal to x cos theta plus y sin theta. V equal to y cos theta minus x sin theta. Now what is this x and y? Let us see. For each point A, B and C. For A, see where is A now? This is x axis, this is y axis. A is to the left side of y axis. What is the distance? X bar to the left side. So minus x bar. X equal to minus x bar. So minus 29.58 mm. Now where is y? Y is at a height of this one. This is your y. A is at a height of y. This is y. What is this distance? Total height 100 minus this y bar. This is the 100 minus y bar. Okay. So this is your y. So in this formula, substitute these values to find stress at A. Now U equal to x cos theta plus y sin theta, and U equal to, substitute these values. Okay. Substitute these values. So U equal to minus 29.58 into cos 45 degrees plus 70.42 into sin 45. You will get U as this one. Similarly, V equal to y cos theta minus x sin theta. Substitute these values. You will get V as this one. So stress at point A, sigma equal to, this is the formula. Substitute all the values here. You will get stress at A. Similarly, for point B, x equal to minus x bar, y equal to minus y bar. If you see the figure, so x equal to, for point, where is the point B? X equal to minus x bar to the left side of y by. Okay. And where is this B with respect to x axis? Minus y bar, downside. Okay. So minus x bar, minus y bar. Okay. Yeah. So this is the, so we need to substitute these values. So U equal to x cos theta plus y sin theta. So substitute this one minus x. So if you substitute all these values, you will get U as minus 41.83, V as 0. Okay. So sigma stress sigma at B equal to, if you substitute in this formula, you will get it as minus 12.33 Newton per mm square. Next, it's C. X equal to, so where is C? So x equal to C, that means this distance. So what is this distance? 100 minus x bar. So x equal to 100 minus x bar, and y equal to minus y bar. Okay. Substitute in the formula, you will get sigma bending stress at C as 3.07 Newton per mm square. Now we need to find the deflection of the beam at midsection. We know that the deflection of beam at midsection formula is delta equal to KWL cube by E into under root sin square theta by IVV square plus cos square theta by IUU square. Where K, what is K here? Constant 1 by 48. Or simply supported beam carrying point load at center. This is the value. Now L equal to 3000 mm, W equal to 500 Newton, E you know, theta also we know, IVV you know, IUU you know. Substitute all the values in the formula, you get the deflection as 1.1425 mm. Now what is the position of neutral axis? We know that to get the position of neutral axis, the resultant stress should be equated to 0. Okay. So what is the resultant stress here? The formula, you know that this is a formula, right? This should be equal to 0. To get the position of neutral axis, should be equated to 0. So sigma equal to 0. So this is when this is equated to 0, and substitute m values and theta values, we will get the relation between V and U as minus 3.831. So this is an equation of a straight line passing through G. Okay. The slope of this line is m equal to tan alpha, which is equal to minus 3.831. So alpha equal to tan inverse this value which is equal to minus 24.37 degrees. Okay, so minus means negative, so it should be in this quadrant, negative. Okay, so this is 75 degrees and this is 45 degrees, this is 135 and this is 75. This is the position of the neutral axis. Okay, this is 75 degrees neutral axis position. Okay, thank you.